या कुन्देन्दु तुषारहार नवना या शुभ्रवस्त्रामृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिभिः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा।
To reflect the rich legacy of CSIR, to celebrate the spirit of scientific pursuit, and to reaffirm our collective commitment to research, innovation, and societal well-being. Once again, I warmly welcome to all of you and thank you for joining us in celebration of 84th Foundation Day. Thank you. Thank you all. Jai Hind.
Thank you, sir, for setting the tone for today's celebrations.
We would now request our director, sir, Professor Bikramjit Basu, to deliver the welcome address. Thank you.
So good morning, Suprabhat. Professor Shangamitra Bandyopadhyay, Director ISI Indian Statistical Institute, Kolkata. Professor Kalabaran Maiti, Director Indian Institute for Cultivation of Science. Dr. Tripathi, Chief Scientist, CSIR CGCRI. Ladies and gentlemen, on the eve of the 84th Foundation Day of CSIR, I welcome all of you to this very auspicious program to remember what CGCRI has done so far and also what is the relevance of CSIR in the present context. So what I'm going to do in the next 15 minutes or so, I'll just walk through a few slides where I'll be discussing more my general vision and then also concepts that how this institute will grow in the years to come. So if you look at that science, technology and innovation in India, so it has gone through several challenges. And if you look at that, am I audible to everybody? The keywords. Am I audible now? So if is it better now? So pre-independence, we have witnessed some of the individual scientific excellence by Professor Meghnad Shah, Jagadish Chandra Bose, Prashanta Chandra Mahalanobis, and many others, and who have done research in this very city in Calcutta. Now, following the independence, Pandit Nehru, our first Prime Minister of India, has actually visualized that this country will grow if the industry will grow, and that led to the birth of several steel plants around India. And also, we need competent technological manpower, and that's why Pandit Nehru's vision was to establish IITs, and that has led to the birth of Indian Institute of Technology, Kharagpur, in around 1950 or around 1950. Then comes the technology denial-driven S&T, and there are various strategic sectors like atomic energy, space research. They started developing technology here in India. Then goes through IP generation and global R&D excellence. Now, what we are currently in 2025, we talk about self-reliant India, which is nothing but Atmanirbhar Bharat. But this is the Atmanirbhar Bharat is a precursor to the Vikshit Bharat that is developed India. Now, it is in 1942 when the concept of CSIR was made by then first Director General Dr. Shanti Sharu Bhatnagar, and now CSIR has expanded from north to south, east to west, total 37 laboratories, more than 10,000 plus dedicated scientific and support staff engaged in R&D activities, spanning from deep ocean to space exploration, and this is the vision of CSIR. And this is a breakup of the different manpower, like scientists. We have around close to 3,500 scientists are working in all different 37 labs. Now, this is what I have also mentioned in the closing ceremony of the Platinum Jubilee. Every great institution or organization around the world are built on three major pillars. One of the pillars is the impactful ideas. Second pillar is talented and dedicated R&D staff, as well as human resources. And third one is the safe and state-of-the-art research infrastructure. Safety is also equally important. Now, coming to CSIR CGCRI, what I describe it as a roots in innovation and branches of excellence. We have 9 branches, means 9 scientific R&D disciplines or divisions, and we have around 319 full-time employees, 87 scientists, including 21 women scientists. So this is the mission of our institute, that is to position CSIR CGCRI as a world-leading institute in ceramics, glass, and advanced materials. And then our vision is guided by the IDEA concept, where I stands for inspiring, D stands for delivering, E stands for engaging, and A is administration. So all the CSIR CGCRI employees, perhaps you are seeing this slide for the first time. Now, recently, there is a lot of discussion at the CSIR central level or highest leadership level. What is the impact of the CSIR in the national context and also in the global context? Why we should have CSIR in this very country? and how the impact can be measured in certain tangible manner. And then this is what I have proposed, is that impact of CSIR is a kind of a complex integral of S multiplied by DVS, where S stands for STI ideas, science, technology, innovation ideas. It should also be driven by national missions, and then also the funding also should be there. Whereas the T stands for technical personnel. And here, if you look at this particular ratio in CSIR lab, technical staff to scientists, that ratio is around 1.5 to 2. Whereas in academia, like IITs and ISC, it's much, much less than 1. So technical workforce has a much larger role to play in order to make CSIR most impactful. That is the message I want to send across to you. And here, they are the custodian of the R&D infrastructure because they work in the shop floor. They also maintain all the scientific infrastructure. And then last one is that capital A stands for administration. Administration should regulate, but at the same time, administration must support all the scientists and technical staff to fulfill our vision of Vikshit Bharat. Right. So coming to what CGCRI, this is some of the signature technologies, and these signature technologies is coming from different R&D divisions. And these R&D divisions, I have mentioned some of the signature technology, but this does not mean this is the only technology we have developed and transferred in last 75 years. There are many technologies, but what is more important, what we are planning to do in next 20, 25 years, and this is some of the major pointers that I have mentioned: semiconductor, quantum materials, green hydrogen technology. Our scientists are working on solid oxide electrolyzer cells, also solid-state batteries, AI/ML mediated discovery of new ceramics and glass, medical devices, technologies for strategic sector, technology absorption, and technology absorption, like some of our technologies like related to sensors, which are very high TRL level. We need to transfer this technology and make sure those technologies are absorbed by the Indian industry so that they get benefited. Now, one such example is the Center for Innovation and Manufacturing Ecosystems for Sensors. And this is what CSIR is leading, CGCIR is leading these large national centers. As you see, several CSIR labs are involved, as well as from the West Bengal, Webel is also involved. And some of the stakeholders include BHEL, Tata Steel, and so on. So this is the three representative sensors I'm mentioning. You have temperature sensor, vibration sensor, and also strain sensors. And they have been tested in some of the pilot scale facilities in Tata Steel. And then also we organized several workshops. Dr. Samir Kamath laid the foundation stone of our CMS building. This is another such technology, Wundercare. This is for the wound healing and wound patches applications. These are scientists from Biomaterials and Medical Devices Division have developed. It is also at the high TRL level. And one of the West Bengal-based company, MSearch, they are going to take it and sponsor it for the clinical trial. AI/ML. So after I take over as director last November, one of the major things that I have initiated is the CompuMat group, that is computational materials group. And this computational materials group, my idea is that this is largely an experimental research lab. This is largely an experimental research institute, but also we have some of the scientists who have either peripheral interest or core interest in the computational materials science and artificial machine learning. What you are going to hear from Professor Sanghamitra Bandyopadhyay after 10-15 minutes is that is going to revolutionize this world in terms of the way we think, the way we perform. Now, this AI/ML can be used as a surrogate to experimental data and also computational data. So the people who are involved in the computational material science, they can also feed the data into the machine learning algorithm, whether it's a regression or classification type of algorithms, and some of the major ML algorithms like support vector machine, artificial neural network, or deep learning that has been mentioned. So this is that I'll give you one such examples of one of our scientists who has done on the glasses. This is the creation of database for glasses. Now, this institute is the only national lab with such a core competence and pilot scale facilities for glass science and glass technology. Now, glasses are multi-component oxides, and this multi-component, how the combination of different components lead to the best combination of mechanical properties or material properties, that is a paramount challenge. And then Indrajit has done this work, and then he has actually got a lot of data from the large database, and then he has found out that this most of the glasses, they have hardnesses below 8 gigapascal. But that was possible because of the large database creation and also applying some of the machine learning algorithms. Now, moving forward, that we just concluded the Platinum Jubilee celebrations, and the Platinum Jubilee is, we had several visitors, and you all have witnessed, but it must have had an impact on each of you so that you continue to do more impactful research. And I would like to remind you that we had the visits of the S&T leaders of around 25, several industry leaders, they have come, and then we have that conclave of the startup as well as the large industries conclave. 3 secretaries of the government of India also visited, and we have several workshops as well. Now, this is the list of the speakers whom you have heard during the Platinum Jubilee. They are who's who in Indian science as far as the material science and technology is concerned. We have Professor Balram, who delivered the National Science Day lectures, and he had a lot of intense discussion with many of the young scientists in very contemporary topics, including blue sky research versus technology-driven research, impact of a research paper versus impact factor of a journal, and so on and so forth. We also had National Technology Day, a lecture by Ms. Nigar Saji from ISRO, and then she also visited several facilities at CGCRI. We celebrated International Women's Day, and that time also I invited Professor Sangamita Bandyopadhyay. Unfortunately, she was not available on that day. And then we had a galaxy of speakers, not only from science of technology, but also from different walks of life. Then we had this Dr. N. Kalai Selvi, who actually graced that CSIR CGCRI
This kind of
Platinum
uncertainty with
Jubilee
respect to the supply chain,
closing ceremony.
with
And
respect to
finally,
this
our
kind of an
minister came.
uncertainty to
So our Honorable
therefore,
Minister
from
of Science and
traditional glass
Technology, Dr.
industry
Jitendra
to the
Singh,
innovative ceramics
graced the
industry,
final
it's a wide
concluding
range.
session of
We
the
could actually
Platinum
now
Jubilee
classify it
on
in
August
themes
28,
and project it in
2025.
themes. Could have some
So-
info.
So CSIR CGCRI in this particular Platinum Jubilee also signed MOU with some of the leading academic institutes like IIT Kharagpur. These are the under progress like IIT Patna and BIT Meshra, as well as that IIT Hyderabad is also under progress. We also initiated more academic interactions with SN Bose National Center for Basic Sciences. So moving forward, we'd like to revamp or refurbish that our Tagore Center as the CSIR CGCRS incubation center, and that discussion was finalized during DG CSIR's last visit a week back.
Yes. And therefore, from traditional glass industry to the innovative ceramics industry, this is a wide range. We could actually now classify it in themes and project it in themes. We could have some infographics, some video films made like that. And the range, you have the optical glasses, you have the insulating bricks, you have radiation shields. In defense, of course, you have the nuclear shielding. In healthcare, whole range, beginning from ophthalmology to the implants, whether it's orthopedics, it's dental, energy, and that is how you also get aligned with many of the flagship programs of Prime Minister Narendra Modi's government, whether it's the Atmanirbhar Bharat, because all this is being indigenous, whether it's Digital India, whether it's Swachh Bharat, whether it's Jal Jeevan Mission, as Professor was mentioning there too. So you're also contributing to the ease of living, providing basic amenities to the citizens of it. So you can understand what is the stream of the work that you're doing over here. It's not because if you go around and tell somebody you're working in a glass institute, they do not understand. They think, okay, glass means glass. Unless it's done. So, and also in many of our futuristic missions, you have a role. For example, in our semiconductor, we have this non-oxide ceramics. We've already rolled out an ambitious plan of having semiconductor the green hydrogen mission, where you have the electrolyzers. In fact, I was asking the professor here, I said, have you got integrated with NCL Pune? And I'm glad he said yes. And then I said, NCL is in a big way into PPP models. So we should also do this, because unless we have an early industry linkage, we
This kind of uncertainty with respect to the supply chain, with respect to this kind of an uncertainty to reach to the marketplace, this is the time and this is the high time that India should realize, and we Indians, responsible citizens of the country, should realize that we have to make this country Atmanirbhar. Therefore, the word, whether it is Atmanirbhar or self-reliance or Viksit Bharat, it is not a statement. It is the need of the hour. It is the need of the hour, whether we like it or not, whether we believe it or not, whether we trust it or not, whether we desire it or not. It is the need of the hour. So we have to now start thinking in this direction. And we have to really plan whichever way the science and technology is to be promoted. Now, first we have to see, do I have the supply chain? This kind of
So before I finish, I thought I would like to mention that at CSIR highest leadership level, we are discussing that what would be KPIs, key performance indicators of CSIR labs. And this is some of the points that has come out very promptly, that green budgeting, like what is the funding that we receive for green technology, footprint of organization in alignment with United Nations Sustainable Development Goals, patent filing in futuristic technologies, then socio-economic impact, national mission alignment, technology commercialization, revenue generated through transfer of technologies, number of citizens, quality of life improved through CSIR technology. That is also important. And last one, international ranking. How is CSIR placed with respect to similar organization like Fraunhofer Institute in Germany or CNRS in France? How is CSIR's impact on the nation with vis-a-vis similar impact that Fraunhofer Institute is created in Germany and beyond, or CNRS Institute has created in France and beyond? And best practice of CSI lab, that is also has been asked by the Prime Minister's office, and this has been also mentioned, that how the research ethics, technology dossier, safe workplace, regulatory handholding, Indian standards compliance, including the regulatory compliance, diversity, equity, and inclusiveness, DEI strategy, that has to be also mentioned. And all those things certainly will lead or will make CSIR CGCRI as a national hub of ceramics and glass in Calcutta, and then also we'll continue to collaborate with several national labs, strategic sectors, companies, multinational corporates like Tata Steel, and many of the MSMEs like Allengers and so on, testing and certification, and also with international institutes. Now CSIR is also thinking to reach globally. So essentially, we would also like to establish our collaborations. We are also talking about the CSIR's foreign lab in abroad. So this is the right time that we should think in that direction, how to establish more collaboration with the international institutes, and also professional networking with so many societies and so on that we have also in CSIR CGCRI. So thank you very much. And now let me introduce today's guest of honor, Professor E. So we are extremely pleased to have Professor Kalabaran Maiti, Director, Indian Association for Cultivation of Science, as our guest of honor. Professor Maiti took over as Director of Indian Association of Cultivation of Science on 19th March 2025 on deputation from TIFR Mumbai, where he is a senior professor. He served in the administration within TIFR and outside in various capabilities, latest being Dean NSF for about 6 years. He completed the undergraduate studies in Calcutta. He is the first ranker in the BSc in Physics at Presidency College and topped MSc in Physics in Calcutta University. He did his PhD as a CSIR Fellow at Indian Institute of Science, Bangalore, and received Toulouse Medal for the best thesis in the Faculty of Sciences at ISC. He did his postdoctoral work as an Alexander von Humboldt Fellow in Zurich in Germany. He is also currently working in TIFR since February 2001. He is a leading scientist in the field of quantum materials, studied by high-resolution electron spectroscopy. He built a state-of-the-art high-resolution electron spectroscopy laboratory at TIFR, a unique one in the country and comparable to the best few in the world. He is well known for his seminal contributions in the field of quantum materials, such as correlated electron system, magnetic materials, iron-based superconductors, and topological materials. He played key roles in promoting bilateral programs such as Indo-German, Indo-Japan, Indo-Italian, etc. He was awarded the title of Honorary DAD Advisor by the President of Germany for outstanding commitment and leadership in promoting Indo-German relations in education. He is a fellow of all the 3 major science academies in India. He received many awards and recognitions throughout his career, including the most prestigious CSIR Bhatnagar Prize in Physics in the year 2010 for his contributions in the field of very high resolution photoelectron spectroscopy in understanding the physics of metal insulated transition, charge density wave, and Kondo system. With this brief introduction to his distinguished career, I now invite Professor Kalabran Maiti.
Good morning. First of all, I thank Professor Basu for kindly inviting me to this very interesting and prestigious meeting, and I'm privileged to be part of this. So, Honorable Chief Guest, Professor Bandyopadhyay, whom I know for many, many years from my student days. So it's very nice to see her become a banyan tree, almost. So reached the highest level of academic excellence in the country. And also Honorable Director of CSIR, Professor Basu, and Professor Tripathi, and distinguished colleagues, students, and everybody else. So as I said, that it's a great honor for me to be part of this celebration, because CSIR actually is part of our life from the very beginning. I was a CSIR fellow when I was doing PhD, and then of course over the years on many occasions, for example, NCL, they have this instituted Mashelkar lecture, which I think I was one of the inaugural speakers. Now NPL, I go almost regularly. One of my good friend, he's the director now, Achanta Venugopal. So I think in academic arena, CSIR is a name which has been contributing significantly. Even now, many of the students who are actually getting CSIR fellowship to do their PhD. So I really highly appreciate the kind of contributions they have been doing. And of course, the most prestigious award, this Bhatnagar Prize, of this used to be handled by CSIR. So I congratulate Professor Basu for leading this institute. He has talked about Navaratna. We know Navaratna in many occasions. So I'm very happy to see that he actually brought out 9 key areas where CGCRI has been contributing significantly. And so this has become kind of a second home, because I think I visited this place in last few months quite a few times. So many of our colleagues from ISCS, they have initiated collaboration with this institute, and they have been doing excellently well. So it would be my pleasure to take it forward. Actually, although I mean I have done my actually the undergraduate and graduate studies here in Kolkata, for many years I have been out. But still Kolkata has a very speciality that I always feel. I mean, when we were actually student, we used to learn that what Kolkata thinks today, India thinks tomorrow. I mean, This may not be true at this moment because we have gone behind on many aspects. However, on one aspect, I think Kolkata still has a signature which nobody has come close to it, is its creativity, innovation, the intellectual capability that houses in Bengal. I think it's outstanding, and we are continuing in that aspect very well. So this is another thing which I guess we need to nurture it and take it forward and ensure that our glorious old days that comes back, that what Kolkata thinks today, that India would think tomorrow. So let me briefly talk about IACS and how it is really linked to CGCRI. You know, Indian Association for the Cultivation of Science, it was established 150 years back. So we have stepped into the 150th year. This is the oldest research institution in Asia, not only in India. And it was established by a great visionary, Dr. Mahendralal Sarkar. So he was a medical practitioner. He was the topper in Calcutta Medical College. And people used to think that he was like a Dhanvantari. We, of course, know about Dr. Vidhan Rai, who has been a legendary figure in medical practices. Mahendralal Sarkar also was somewhat similar in his time. So, I mean, one example is that in the British era, the highest paid doctor who are most trained used to get a visit 16 rupees for each visit. Mahendralal Sarkar used to charge 32 rupees. So this shows that how great his practices used to be. So he realized that under British government, I mean, although they have created this University of Calcutta, University of Madras, and so on, but these are all basically with an idea that benefits British to rule the country in a better way. So Mahendralal Sarkar realized that we need to train our Indians in modern science if we want to really progress and be a leader in the future. So that was the idea, and he, of course, then started this institute from his personal earning. This is a unique example which was actually created. Similarly, I think most of the institutes in Kolkata, if I know correctly, these are not really funded by a billionaire or somebody, some big king or something. These are all created by philanthropic contribution of great visionary people. So IACS was contributed by, of course, Mahendralal Sarkar. The first trustee members are Ishwar Chandra Vidyasagar, whom we know, I mean, one of the greatest reformer of the time, Keshav Sen, and so on. And his love for the modern technology, one of the example is that, you know, when the X-ray was discovered in 1895 by Röntgen in November, the paper was published. Mahendralal Sarkar immediately got a Röntgen tube imported from England, and he started doing experiments. And he's the first one who got an image of a hand using these X-rays in 1896, within few months in June. And of course, then after Jagdish Chandra Bose, he was working in Presidency College, but he was a regular teacher at IACS. So he improved the source and he got a better quality image, and then we started using it for medical practices. So, I mean, this is the lab for the advanced technology, which is very, very important that if we want to go ahead, that is required. And then, you know, of course, C.V. Raman joined IACS, and we got the Nobel Prize. So all these examples, I mean, any name that you think of, Satyen Bose, Meghnad Saha. Actually, the present campus was established by Meghnad Saha, who is another greatest mind of the time. And the campus was inaugurated by Dr. Vidhan Rai. So if I am not wrong, Although the first Director General of CSIR was Bhatnagar, the brain behind creation of this organization, one of the brain was Meghnad Shah. So he actually he is of course the creator of two National Science Academy, INSA and NASI. And you know the IAS, Indian Academy of Sciences, was created by C.V. Raman. So basically, the progress in science and its nurturing that we have been seeing or witnessing today, it has a great link to Kolkata, because all these people who created these academies which are leading the academic society is actually originated from Kolkata. And today, I'm extremely proud to see that any of the recognitions that India has achieved, whether it's arts, films, and literature and science, Kolkata has played a leading role. And I think 2023 Nature review that they found that how different cities in India, they are contributing in science. And they found that Kolkata is the top science city in the country still. So I think there is nothing to be, considering various situations and so on, there is nothing to be sad about it. I think we are still doing excellently well. And we have a lot of scope to contribute well in the progress of our country. And like the CGCRI, I think they have been doing a lot of innovations and leading it to the technology which helps us to become self-reliant. We at ISCS, we have a great group of scientists who has been doing a lot of innovative work. I think ISI is one of the leading institutions in maths and statistical physics, computer science, and so on. So we have a lot of scope, and I think we can get together and strengthen ourselves and become again the leader, not only in country, also leader in the world. So it's really very nice to see the future progress. And I wish you all the best on this special Foundation Day, and hope that we have much brighter future ahead. Thank you very much.
Thank you, sir, for sharing your thoughts with us today. Now I would request our director, sir, to introduce our chief guest.
It gives me absolute pleasure to introduce today's chief guest, Professor Sanghamitra Bandyopadhyay, who did her BTech, MTech, and PhD in computer science from Calcutta University, IIT Kharagpur, and Indian Statistical Institute, respectively. She then joined the Indian Statistical Institute as a faculty member and became the director in 2015. Since 2020, she is continuing in her second tenure as the director of this renowned institute. Her research interests include computational biology, soft and evolutionary computation, artificial intelligence, machine learning. Professor Bandyopadhyay has worked in many institutes and universities around the world. She is the recipient of several awards, including the Shanti Swarup Bhatnagar Prize in Engineering Science, TUAS Prize, that is the World Academy of Science Prize, Infosys Prize in Engineering Science and Computer Science, J.C. Bose Fellowship, Sono Jayanti Fellowship, Indian National Academy of Engineering Silver Jubilee Award, Indian National Academy of Engineering Women Engineer of the Award Academia, IIT Kharagpur Distinguished Alumni Award, Humboldt Fellowship from Germany, Senior Associateship from International Center for Theoretical Physics, Italy, Young Engineer Scientist from International Science Academy, INE, and ISCA, and Dr. Shankar Dayal Sharma Gold Medal and Institute Silver Medal from IIT Kharagpur, India. She is a fellow of all the National Science Academies and the Engineering Academies of India, IEEE, the World Academy of Sciences, and International Association for Pattern Recognition. She serves as a member of the Science Technology Innovation Advisory Council of the Prime Minister of India. In 2022, she was conferred the Padma Shri Award of the Government of India.
Hello? I'll take it pointed, right? A very good morning to all of you. Professor Kalaburun Maiti, Director, Indian Association for the Cultivation of Sciences. Professor Bikramjit Basu, Director, CGCRI. Dr. H.S. Tripathi. All colleagues from CGCRI, students, researchers, friends, ladies and gentlemen. It's a great pleasure to be with all of you today, celebrating the Foundation Day of CSIR. It is the 84th Foundation Day, and the day is still 2 days away. I think today is 24th, it's 26th of this month. Plus, this is also the Platinum Jubilee year of CGCRI. So it has, it's a really important occasion. And 26th September used to be, at least, a very important day for most of the scientists of India. We have looked forward to the CSIR's announcement of the Bhatnagar Awards on that day. And 2010, I am so happy to be sharing the stage with Kalaburun Maiti. We received in 2010 the information on 26 September, I think, on, together, and received the prize together also later on. And CSIR, of course, I've been, as Kalaburun Maiti also mentioned, I've also had some association with CSIR in the past. I was, after my PhD, a CSIR RA for a few months. And then in the not so, I mean, in the relatively recent past, I have also been a member of the CSIR Society. So that way I was, when Dr. Shekhar Mande used to be the DG. So I have had close relations with CSIR, and I've seen its growth. And particularly when Professor Basu presented his vision, his ideas, and what has been achieved. It's something worth appreciating and also feeling very good about, that the future is in very good hands. Today, I'm going to talk about artificial intelligence. It's everywhere. Everybody is talking about AI in almost all domains that you can think of. So what it is, how it evolved, I just wanted to make a presentation, and Professor Basu has, of course, alerted me quite a few times that it should be at a very general level. And of course, it's not that I understand too much. It's only a little bit, because it's a vast area now. So I will try to walk you through how AI developed, where it stands now, and what are the caveats for the future. What are the things that we have to be alert about? Before I go on to that, I'll just quickly introduce the Indian Statistical Institute to you. It is an old institution. In fact, I think ISCS is the oldest here, and then Indian Statistical Institute, and then CGCRI. We were established, ISI was established in 1931 in Presidency College, and it was there for a few years, and then it moved to its present campus. You can see the picture at the background. It is close to Dunlop, and Mohalanobis, you can see the picture here, is the founder of the Indian Statistical Institute, and is the father of the statistical sciences in India. So he was also a physicist. I mean, he was a physicist by training. He taught physics in Presidency College, but then he got interested in this area of statistics while returning from UK during the First World War. And then he never went back. He stayed on and started ISI in 1931. He was, in fact, the first secretary, I think, of Vishwa Bharati University, along with Rabindranath's son. But then there were some differences, and then he came out and established ISI very much in the pattern of Vishwa Bharati. If you come to ISI sometime, or if you're visited, you will see outside the Barakpur Trunk Road and inside ISI, there's at least it's a lot of trees and water bodies and nature, and so it's a nice place. As you were mentioning, Professor Maiti, somehow these people really at that time had a great vision.
So they had thought ahead of time. Computer, that it is going to be extremely important, was figured out by Mahalanobis, and he got the first computer in India to the Indian Statistical Institute. The first computer to be developed in India, also between with a collaboration between ISI and Jadavpur University. That is why it was called ECJU, ISI-JU. And parts of it are still there in the Birla Industrial and Technological, in the National Science Museum here, NCSM. And he is also very well known for something called the Mahalanobis distance, which many people use in their particular research domains. We are, of course, not just in Kolkata. Kolkata is the headquarters of the institute. We have centers in Delhi, Bangalore, Chennai, and Tezpur, and we have a branch in Giridih. We have small units in Hyderabad, Mumbai, and Pune. So we are spread all over the country, and we have, as you can see, some scientific divisions, 7 scientific divisions, and these are the programs that we run. Of course, PhD is mostly in statistics, mathematics, economics, and computer science, and related areas. We have some very interesting programs, of course. We also have 3 undergraduate programs now, and 8 master's programs, some diploma programs, including one, this PGDBA is very interesting. It's postgraduate diploma in business analytics. 3 institutes together, we run this program, ISI, IIT Kharagpur, and IIM Calcutta. And the students actually move physically from one institute to the other, 6 months in each, and the last 6 months is for dissertations. So with that, let me come to the topic of my talk today. Computer has evolved over a number of generations, including from the analytical engine in 1812. It was just a thought at that time by Charles Babbage, to vacuum tubes, through transistors, integrated circuits, VLSI, to the 5th generation, which is ultra large scale integration. And in fact, it's going beyond that now. I will tell you in the, here you can see. So the Moore's law, which has held surprisingly long, which states that doubling of the number of components per chip every 2 years. It has actually held for a long time now, but it has slowed down dramatically because we are reaching the physical limitations now. And therefore, disruptive technology is what is expected. Every time we've neared the end of something, some disruption has happened, disruptive innovation has happened, which possibly will take us to the 6th paradigm through quantum computing, as well as 3-dimensional integrated circuits now. It's, you have in layers, ICs are connected in layers in a single chip. So that is where things are going these days. Similarly, this is just hardware part. Similarly, it has the science, with the 4 paradigms of science also. It's empirical science, many thousands of years back, to theoretical models, etc., hundreds of years back, to simulation-based science progress. And now we are in this 4th paradigm where data is driving science. So a lot of data-driven science is now ongoing, and this necessitates, of course, much greater collaboration between the industry, academia, and the government. So here is where we stand. And as you are all hearing these days, artificial intelligence, machine learning, and deep learning. What is it? Just this picture just gives you a broad view of what it is and where each component stands. So the larger set is what is artificial intelligence, which we've been learning for many decades now. Okay. A subset of artificial intelligence is machine learning, where the machine will start learning by giving it certain examples or something. The algorithms will be there, which will let the machine learn certain things, not just told certain things. Okay. And within it, there is this deep learning, which is a subset of machine learning, essentially based on artificial neural networks. Okay. And this is where, with deep learning, why is it deep? Because artificial neural networks have also been there for a long time. It's deep because the number of layers or the number of neurons, number of connections has become very large. So that is why it's called deep learning. Now, just to tell you again, this there's a confusion, a little bit of confusion between what is AI, what is not, what is AI, what is ML, and what is not ML, but AI. Okay, so just to give you an example of what is machine learning, let me tell you what is artificial intelligence, what belongs to the category of AI, but is not machine learning. For example, you have, this is not a very good example of that, but I'll tell you that we used to use expert systems where the rules were told that if X is the father of Y, Y is the father of Z, then you can infer that X is the grandfather of Z. So these rules were told, hard-coded, and then the system inferred. That is artificial intelligence, but it is not machine learning. When does machine learning come? It is something like this. When I'm giving the system examples of dogs and cats, and then I give it a picture of a cat, but this picture it has not seen anywhere before. Okay, it is through these examples that the system has learned to distinguish between dogs and cats. Now, once it's given a new picture, it is able to tell. But I've not told it how to figure out what is the difference. It has learned it on its own. So that is what is machine learning. Now, how did it start? How did AI start? Alan Turing is considered to be the father figure of artificial intelligence, an English mathematician, computer scientist, logician, cryptanalyst, many things in one. And he was considering thinking machines way back in 1941. Okay, around 1943, the first model of a neuron was developed, artificial neuron, of course, not the real one. And in 1950, this imitation game, Turing designed a Turing test. If a computer program passed the Turing test, then it could be called intelligent. Okay. So what was the Turing test? The Turing test was that suppose there's a computer and a human being in another room, and the interrogator is in this room, and the interrogator just through written text is asking some questions, and either the computer or the human is responding. Okay. Now, if the interrogator is unable to tell whether the human or the computer has responded sufficiently high number of times, then it can be said that the computer has been able to fool the human interrogator. Okay. So if the interrogator cannot reliably differentiate the computer from the human, then the Turing test is thought to be passed. It has proved to be really difficult to pass the Turing test, and CAPTCHA, as you know, we always run with do CAPTCHA. CAPTCHA is reverse Turing test. This is just an information. It's reverse Turing test where the computer determines, not the human. The computer determines if the user is a human or a computer. Okay, so that's CAPTCHA. It's reverse Turing test. The Turing test was sort of passed for the first time in 2014, where this system called Goostman, it was able to fool 33% of the judges. If there were 100 judges, 33 were fooled by this particular software into thinking that this was a 14-year-old Ukrainian boy responding. So 33% of the judges. But that was not the real Turing test. Sort of Turing test got proved here. But AI officially passed the Turing test in 2025, and we'll come to that later in a while. This Turing test, of course, had its fair share of criticism, including from an American philosopher called John Searle, who forwarded the Chinese room argument, which says that if a computer is able to take questions in Chinese and respond to that, doesn't mean that the computer understands Chinese. So that was the criticism here, that strong intelligence is really if it understands Chinese, but weak intelligence merely simulates that as if it understands Chinese. So there was a lot of this criticism around it, and that criticism also went on for quite some time. But then development happens. Criticisms don't stop development. So further development happened. In 52, the Samuel Checkers playing program was developed. In 56, this is important, in 56, in this Dartmouth summer research project on artificial intelligence, this is considered to be the founding event in AI. Okay, here McCarthy, Minsky, Rochester, and Shannon, they coined the term artificial intelligence in 1956. in 58, the term machine learning got coined. And also an important development happened here. Rosenblatt, this person, he developed perceptron, which forms the basis of artificial neural networks in later time. And just quickly, what a neuron is as simple as this. This is just a small node, okay, which takes several inputs. So the inputs are coming x1, x2 up to xn, and each line has some weight. And these inputs, they are multiplied by the weight. So you have this wixi plus a bias term bk and a function on that, which then goes into the output. Okay, and this is usually like if it is above 0, then if it's a positive value, then output 1. If it's a negative value, then output 0 or something. Just a 2, usually a 2-level output here. And if you think of it, it actually is a linear classifier. It's a line because this wixi plus bk defines a line, and that line is the distinguishing boundary between two classes 0 and 1. So essentially, that's what a neuron does. Of course, then these threshold functions were changed, and a lot of other innovations happened. But this is essentially what a neuron does. And if you have a number of such neurons and they are connected, what do you want to do? What you want to do is you give it certain input data and you know what you want as the output, but the system goes through, the input goes through the system, but you don't get the desired output. So you measure the error, how much the system has output and what is your desired output. And then this error, I mean, if you look at it in your search space, the error surface is very complicated. And what you have to do is to somehow go to this minimum value of the error. That means you have to set your parameters in such a way that you are able to reach to the minimum value of the error. Okay, and usually the gradient descent algorithm is used. So you start from somewhere and then move towards the negative of the gradient. You move towards the negative of the gradient with the hope of landing up in this the minima. But then because the space has so many local minima that you are more or less guaranteed to get stuck at a local minima by this method. But this is what is the usual method of steepest descent or the gradient descent. So I'll not go through these algorithms here. I hope you've just got an idea of what a perceptron is. So I'll move on with that. So the development continues with AI. In 64, a natural language program called Student developed an NLP program student during his PhD. Okay, that was one first sort of AI-based expert system was developed. 65, the first expert system called Dendral was developed, which was a medical expert system. Okay, it assisted organic chemists in identifying unknown organic molecules. 66, the first chatbot Eliza was developed, and Stanford Research Institute developed Shaki, the first mobile intelligent robot. This continues. Then in 69, there was a winter. An AI winter happened because there was a book published by Minsky and Papert called Perceptrons: An Introduction to Computational Geometry, which showed the limits of artificial neural networks. Okay? And it hit a winter. What they showed? They showed very simply that if you have the XOR problem, meaning there are 4 points here, these 2 points belong to the same class, and these 2 points belong to another class. So this is, let's say, class 1, and this is class 2. Remember, our neuron, it can only draw one line, and none of the lines will be able to distinguish between these two classes. Whatever you do, with a single line, you can never distinguish between these two classes, right? Because of the arrangement of the points. And this is a very, very simple problem, XOR problem. So that was first demonstrated by Minsky and Papert, and then everybody lost faith, lost hope in AI. The research funding went down, what happens usually. But then it re-emerged, okay, around the 1980s with the development of an algorithm called backpropagation. There were many neurons, and then how you backpropagate the error. That was developed by Rumelhart, Hinton, and Williams. And you will remember the name of Hinton because in 2024, he got the Nobel Prize, okay, for this work, essentially. Okay? And then the convolutional neural networks, which is a deep neural network these days, it was also developed around this time between 1989 to 1998, which was able to recognize handwritten digits. Okay, so and then several developments happened, including a very interesting development in 96, 97, where IBM developed a system called Deep Blue, and this was developed specifically to defeat Kasparov, Garry Kasparov, the reigning world champion at that time of chess. So IBM's Deep Blue, it played with Kasparov a pair of 6-game matches, 6 games and 6 games. In the first match, meaning a set of 6 games in 1996 in Philadelphia, Kasparov won 4-2. But then it already showed there was a computer program which could defeat a champion in a game, because 2 games, the Deep Blue won. Okay? Now, in a rematch the next year in New York, Kasparov lost. Okay? Kasparov won the first game, Deep Blue won the second, then draw, and then Deep Blue won. So 3.5, Deep Blue won the match. And for the first time, a computer program defeated a world champion in a chess match. And this actually led to a very interesting documentary, Game Over, Kasparov and the Machine. This is a documentary. I think it was made in Canada. So now it went on. In 2009, we have GPUs to train large neural networks. Okay, now the system resources are increasing, memory is increasing. 2012, AlexNet with the student Alex. It was also by Hinton, whose student was Alex. AlexNet was developed, which actually took as input humongous amount of number, trained a very deep learning system with those images, saying nothing except just giving those images as input and telling that this is the image of this is the image of that, that's all. Okay? And the system was then able to learn and also predict that if you give it an image, what it contains. Interest in deep learning at an all-time high because of this work by Hinton and his students. 2013, reinforcement learning got introduced. In 2014, something called generative adversarial network, that was introduced, okay? And it's very interesting, actually. There are 2 neural, remember that all these are based on artificial neural networks and nothing else, okay? And in GANs, it's very interesting that there are 2 networks, 2 artificial neural networks, very deep. It's many, many neurons and many, many connections. And they are actually adversaries of each other. This is trying to fool this, this is trying to fool this. So what happens is you have real images, and this system is generating false images, artificial images. And if this system gets an input, an image as an input, this system is supposed to tell whether this is a real image or a fake image. So initially, it is not able to tell. So it gets trained because there's training data, it gets trained. But once it is trained and it is able to tell that this is a real image and this is a false image, then its training starts. The generator's training starts in a way that it is able to again fool the discriminator. And this competition goes on till the system stabilizes. Okay. And thereafter, this system, this generator is now capable of generating very, very real life images. So that is what the generative adversarial networks are used for when you have little data. Suppose there are you have a 2-class problem. You have only 10 data points in one and you have 90 data points in another. Then you have a problem actually in classifying that. Now you have to increase the one which has very few data points. There you can use things like this to generate very real life but artificial data points. Okay, and this has a lot of applications. In 2016, DeepMind's AlphaGo defeated the Go player. In 2017, diffusion model was developed, whereby given a absolutely noisy image, you can design fantastic new images. Okay, and the concept of transformers came, which was path breaking. It was a paper, Attention is All You Need. That is the title of the paper, which led to the development of large language models. Nowadays, you must be hearing large language models, the word also. In 2018, OpenAI releases GPT, okay, generative pre-trained transformers. GPT-3 in 2020, ChatGPT in 2022, and ChatGPT-5 in 2025, very recently, okay? And Bengio, Hinton, and LeCun, they win the 2018 Turing Award for their work on deep learning. 2021, OpenAI, this is the company which released the GPT. It releases DAL-E, which can generate. You give it a text prompt that I want a picture which is like something made by let's say Jamini Roy, and which should have this, which should have a horse, which should have a train and whatever, and then draw it. So it will do a really, reasonably good job. You can try it out. So Turing test passed. I said I'll come back to it later. ChatGPT 4.5 in a UC San Diego study conducted by Jones and Bergen, the participants held 5-minute conversation, text conversation, of course, with a human and a Gen AI model, but was not able to see who's participating in that conversation, whether the human or the Gen AI. Gen AI meaning generative AI, which is generating text. And they had to guess which one was the artificial intelligence system. And the ChatGPT 4.5 model was so convincing, it was judged to be human 73% of the times. Imagine, the ChatGPT was judged to be a human by several participants 73% of the time. So it really passed the Turing test, while other models were much poorer. So this is what I meant when I said that Turing test was passed for the first time fully very recently. So, with this particular model, ChatGPT 4o Mini, I had a conversation. How to give an interesting keynote lecture. And it gave me, of course, some very well-known points that you must know your audience and you must have a strong opening, etc., etc. And it went on to give me additional tips also. You can see here, choose attire that suits, dress appropriately, okay, and use humor wisely. Very interesting and very appropriate inputs to have a talk. When I asked it, of course, I can also prompt it that, no, you've given me a very long answer, give me a shorter answer. So it actually shortens it. And it can do a lot, actually. If you think about it, it's mind-boggling, amazing. Now, the thing is, why did such research move in spurts? Why was it not a exponential rise like this? Because although the theory was ready, technology was yet to catch up. We did not have enough storage. We did not have enough computational power. Once that became available, then there was no stopping what is happening these days. So you will see now huge amount of data and the capability to process huge amount of data. That was very important. The storage costs have come down, and systems have become extremely powerful. The GPUs which are there, extremely powerful. So the benefits of AI, of course, we all know there are many benefits, including, you can see AI in agriculture, where you can detect diseases, you can spray appropriately, etc. Lot of applications of AI in agriculture. AI in e-commerce, we all see when we are buying something, the system is prompting us to buy something else. How does it do? Again, there are principles of artificial intelligence which are over there in inventory planning, churn prediction. You can use churn prediction, meaning when is a customer likely to leave you? So the company has to know beforehand that this customer is now going to leave you. Let's say a telecom company. If the customer is likely to leave you, catch on, because getting a customer and then holding on to the customer is an expensive affair. So then you have to predict that churn, that this customer will be churning, and do something about it. Maybe give that person some additional SOPs or something. AI in urban planning. How do we plan the system, the traffic intersections and everything? It's very much there everywhere. Okay. AI in weather prediction. It did predict, of course, that it's going to rain very heavily, but probably not the level that we had. Okay, so there are a lot of scope for improvement, and that will sustain us for the years to come, because slowly the systems are moving in such a direction, looks like we are becoming redundant. So not yet. AI in policy, okay, a lot of evidence-driven policy making, that's the mantra of today, and a lot of AI goes into that. And because I was coming in CGCRI, so I thought it would be unfortunate if I don't say something about glass and ceramics, which I have absolutely no idea about. So, but I just saw that there is one paper, 21 challenges for the 21st centuries by a group from IIT Delhi and UCLA, I think. So this, like, two of the challenges, of course, I think Professor Basu has already mentioned this, that predict the properties, if given a composition, can you predict the properties using AI and better models? And if you have certain properties in mind, then you predict the composition of glass, for example. These are two problems, but then 21 such challenges have been listed out in that paper. So the challenges, of course, high dependence on machine and minimal human intervention can be risky. These models are known to hallucinate, meaning tell a wrong answer with high confidence. Okay? So they are known to hallucinate, and you cannot really 100% rely on these things. You will remember that in the recent past, one advocate, he submitted a document to the court where he had argued the case and given certain very old case records, which was all very nice, except that none of those cases existed. So the system had made it up. Okay, you cannot really rely fully on that, because then if you have critical applications, you can land up with wrong medical diagnosis, wrong predictions, etc. And there are a lot of biases, there are a lot of issues with artificial intelligence yet. Explainability is very low. The system is so complicated, nobody knows how it is saying whatever it is saying. Okay, and that for medical professionals, for example, they will not accept. Okay? You have just that the data was input and said that, okay, this person has so-and-so disease is not sufficient. The system has to be able to explain why it said so. So explanation, and with that comes trust. Only if you explain well, then the trust will be there. So these are important issues now, and regulations governing AI still not properly in place. However, recent recognitions to AI in 2024, the Physics Nobel Prize was awarded to Hupfield for discovery, discovering this associative memory, which can store and reconstruct images. It has stored images. Now you give my picture, for example, just of this part. It will be able to figure out that me. It will be able to recognize. And Geoffrey Hinton, as I said, for the backpropagation algorithm, for training neural networks, and also for AlexNet with his students Alex and Ilya. These were two students of his. Chemistry Nobel Prize recognized David Baker for AI methods to design entirely new proteins on computers using AI tools, and Hassabis and Jumper for AlphaFold, an AI algorithm that accurately predicts protein structures. So AI has now entered the domain of Nobel Prizes also. So it's well on track. What are the issues? As I said, they hallucinate, give wrong answers with high degree of confidence, bias and fairness, because it is so dependent on the data, on the algorithm, etc. If there is bias in the training data or in the algorithm design or in the designer's mind, then the system will be biased. Okay. Ethical concerns are there. Suppose something goes wrong. Okay. Who's to be blamed? And nowadays, with all this plagiarism thing, that AI is generating text, but it is taking, snippets from here, there. Is it plagiarizing? What is it doing? So that is what is ethical concern, transparency and accountability. Who's accountable? If an automatically driven car is involved in an accident, who is it? Who's to be blamed? Okay. Security, safety, of course, nowadays with digitalization everywhere, security is a great concern. Okay, you will know about the hacking into a French hospital system where everything came to a standstill. So these are major concerns now. And deepfake in a country like India, with deepfake, you can understand with so many people, billions of people, it is so easy to, create havoc by showing pictures, videos of events which never happened, which with voices or words which were never spoken, just generated. It can be really, really dangerous. So again, I'll not go into the challenges, but I will just give you 2 slides of the caveats, which is in February, I mean, people who were involved in the development of AI themselves are now waking up to the grave dangers now being posed by AI. In 2023 February, a New York Times technologist column reported that he was deeply unsettled after a chatbot that's part of Microsoft's Bing search engine repeatedly urged him to leave his wife in a conversation. I mean, they're playing with the mind. That is where the danger is coming. It's playing with the mind. May 2023, AI algorithms will soon reach a point of rapid self-improvement that threatens our ability to control them. That is something which is of great concern. Spread of disinformation, as I already said, can create social tensions when in the wrong hands. But so is nuclear power, right? In the nuclear energy, in the wrong hands, it can create havoc. So use of the technology has to be very responsible and regulated and controlled. Okay. It is most problematic when it starts manipulating the human brain. Okay. And many people in doyens in the domain of AI have actually written to stop the developments now, put all the regulations in place, and then move on. But that one can only wish that happen, but that is not going to happen. It will continue. And then Hinton himself, right? He announced his resignation from Google because he sort of regrets his work. And not only that, he wants to be free from all these restraints of working in a company to be able to speak out freely. So he said, right now, they are not more intelligent than us, as far as I can tell, but I think they soon may be. And Hinton's word need to be taken seriously. Benjio, again, a doyen of AI, thinks that we need to take a step back now. Issues of trust, privacy, transparency, accountability, ethics, all are there. And the rise of artificial general intelligence, I will just conclude with a statement here. Make no mistake, we are on a speeding train right now. And the concern is that one day it will start building its own tracks. That is the main concern. So if you have any questions, I'll be happy to take them. And thank you very much for your patience. And of course, my acknowledgements to all who have helped me do whatever I have been able to achieve. Thank you very much.
Madam, hello.
यत्र नर्यस्तु पूज्यन्ते रामन्त्रि तत्र देवता यत्रैतस्तु न पूज्यन्ते सर्वस्तत्राफलः क्रिया. The gods reside at the place where women are respected. Where women are not respected, all good deeds and religious practices become fruitless. We now move to the release of a very special compendium. This compilation, Her Legacy at Work, highlights the remarkable contributions of women at CSIR CGCRI. I request all our dignitaries to come to the stage to kindly release the compendium. I also request Dr. K. Annapurna, Chief Scientist, Specialty Glass Division, to come to the stage for this purpose. This is a proud moment honoring the dedication and achievements of our women who have strengthened our institute over the years. This volume weaves biographies, memories, and contributions into a living record that honors tradition and the spirit of service that built this institute. Congratulations to all the editors, contributors, and every woman featured here. May their stories inspire many more generations.
May I now request our director, sir, to felicitate our esteemed chief guest. Chief guest. Madam, this stoneware flower vase is a creation of our Khudja Center. May I now request our director, sir, to felicitate our guest of honor.
कर्मण्येवाधिकारस्ते मा फलेषु कदाचन मा कर्मफलहेतु भूर्मार te sangastva karmani. You have only right to your actions and never to its fruits. Let the fruits of action not be your motive and also never remain attached to inaction.
Now we move to the official felicitation ceremony. We also celebrate today our colleagues who retired last year. Though they have stepped away from their official roles, their dedication, wisdom, and years of hard work remain a guiding light for us all. I would request our Reverend Chief Guest, our guest of honor, and our director, sir, to present them with a small token of appreciation and a small gesture of our deep respect and gratitude for the immense legacy that they uphold. I would request them to come to Sri Biplav Noskar, Srimati Krishna Bhattacharya, please. I think the others also be ready. Sri Sanatan Naya, Dr. Milan Kanti Noskar, Dr. Nandini Das, Sri Tapos Ghosh, Dr. Shitandu Mandal, Dr. Abhijit Ghosh, Dr. Somnath Bandyopadhyay, Sri Shubhendu Chakraborty, Dr. Torun Koyal, Sri Mithilesh Prasad, Sri Swapun Sarkar, and Sri Durjodhan Sethi.
It's time to honor the employee who has completed 25 years of continuous service between September 2024 and August 2025 and who is on CSIR rolls as on 26 September 2025. Mrs. Ratna Bhattacharya, ASOG, please come to the stage. She is not here. Okay. Vidya dadati vinayang, vinayadyati patratam, patratva dhanam apnoti, dhanar dharmang tatang suphang. Knowledge gives humility and humility gives worthiness. By being deserving, one gets wealth, and after wealth comes religious fulfillment, and from it, one ultimately finds happiness in life. We also proudly recognize the children of CSIR employees who have excelled in academics this year. In the first category, studentship cash award of rupees 1500 per month to the children of CSIR employees, we will order Ms. Debarati Shomadar, daughter of Sri Ranjan Shomadar, for her admission in IIM Shambhalpur through CAT this year. Next in this category, Sri Onkur Ghosh, son of daughter Shourja Ghosh, for his admission in IIT Kanpur for BTech in Chemical Engineering. Next, Ms. Shomi Dana, daughter of Dr. Kaushik Dana, for her admission in IIT Madras for BTech in Chemical Engineering. Sri Onkur Ghosh and Ms. Shomi Dana will be honored for other two categories also. That is one-time lump sum cash award of rupees 3,000 to the children of CSIR employees who secured 90% or above in each of minimum 3 science subjects in the senior secondary exam. And one-time lump sum cash award of rupees 2,000 to the children of CSIR employees who secured 100% in any science subjects in the senior secondary exam.
I think we move ahead now to the felicitation of our own employees and the awards of the employees. So first we'll go with the debate competition for CCCI staff members. Mohammad Mursalin, please, has won the first prize. Mohammad Mursalin, please, first. Mr. Saptarshi Ghosh, second prize for the debate competition. Mr. Raja Noshkar and Mr. Sudipta Sardar. Mr. Saptarshi Ghosh, Mr. Raja Noshkar, and Mr. Sudipta Sardar. They are not there. Please, Raja, first. Mr. Saptarshi Ghosh, Mr. Sudipta Sardar. Madam, we have had also sit and draw competitions and recitation competition for the words of the employees. And I would like to now call upon the first prize in group 2, Priyangshu Kopai, son of Mr. Somir Kopai.
Second prize to Second prize goes to Sri Jyotishko Sannal, son of Dr. Ambarish Sannal.
And the third prize to Anamita Rai Chaudhary, daughter of Dr. Atoshi Pal. This is in group 2 category. Group 3, first prize goes to Rishikesh Anand, son of Mr. Shardanand Kumar. Second prize goes to Obipsha Barik, daughter of Mr. Shivashish Barik. think he's not there. Then Annesha Gorai, daughter of Mr. Amit Gorai, for the third prize. And we have a special prize in Group 4 of Ananya Bainipoti, daughter of Mr. Rajesh Bainipoti. Now we have the recitation competition for the Group 2. First prize goes to Mohana Das, daughter of Dr. Mithun Das. Acha, acha. We regret this small delay. The second one, Monjima Das, daughter of Dr. Mithun Das. First prize in Group 3, Monjima Das. And the second prize, Obibsha Barik, Dr. of Shivashis Barik. Thank you, madam. Thank you, sir. We congratulate all the wards and their proud parents. Thank you.
Now I'd like to inform the August audience that CSIR CGCRI is not only thriving in multidisciplinary research in science and technology, but we are also complying with the provisions of Government of India in Rajbhasha implementation. As the nodal office of the Town Official Language Implementation Committee, Kolkata, CGCRI has been coordinating the Rajbhasha implementation related work of 68 government institutions of Kolkata. I'd like to invite on stage Sri Sanjeeva Kumar Singh, our Hindi officer, to receive the certificate of inspection from our director. Please welcome him with a round of applause. The Parliamentary Committee on Official Language, led by Sri Bhartrihari Mahtab, Member of Parliament, along with other MPs and officials, inspected our TOLIC and 6 of our member offices and adjudged our performance as good. Our director, Professor Bikramjit Basu, was awarded the certificate of successful inspection by the Parliamentary Committee. We are truly blessed to have a leader who not only leads us in science and innovation, but also inspires us in Rajbhasha implementation.
Now to conclude today's celebration, I invite Mrs. Munmun Gupta, Administrative Officer, to propose the vote of thanks.
Good afternoon. On behalf of CSIR CGCRI, it is my proud privilege to extend a deep sense of gratitude to everyone who has made this CSIR Foundation Day celebration truly memorable. First and foremost, I express our heartfelt thanks to our chief guest, Professor Shanghamitra Bandyopadhyay, Director ISI, for gracing this occasion with your presence. Your inspiring words have motivated us to continue striving for excellence in the field of science and technology. I also convey our sincere gratitude to our guest of honor, Dr. Kalovaran Maiti, Director ISES, for being here today and encouraging us with your valuable words. A very special thanks to our director, CSIR CGCRI, Professor Bikramjit Basu, for his vision, leadership, and constant guidance, which continue to steer our institute towards greater heights. I would also like to acknowledge the efforts of all our scientists, staff members, and researchers whose dedication and hard work embody the very spirit of CSIR and contribute to nation building through innovation. Our gratitude extends to the organizing committee, volunteers, and support staff who work tirelessly to make this event a grand success. Last but not the least, my heartfelt thanks to each one of you present here today for taking the time to join us and make this celebration more meaningful. As we conclude, let us carry forward the vision of CSIR to serve society through science, technology, and innovation. Thank you. And I request all of you for the national anthem. Please stand up.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
All.
Thank you so much, audience. There will be a vibrant cultural program at 3:30. We invite you all to attend the program. Thank you so much. Have a good day.